Hello everyone, welcome to Urban Subnet. Tonight we're going to talk about EtherChannel again. EtherChannel is a process of combining interfaces together so you can increase the bandwidth or have a combined total bandwidth of the interfaces that are in the EtherChannel group. I call it virtualization in a way because you take the physical ports and you combine them together, make a virtual link between the two switches. It's kind of like, imagine having a house and through virtualization make it possible for 5 families to live in the same house. Each family occupies the exact amount of space in the house, and neither of the families know about the other families. They live in a house in their virtualized homes, they decorate their homes, they paint their walls, and life is good for each family because in their world they have their own house. This is kind of like what it's like in virtualization. You can't do that with your physical house, of course, but you can do this with switch, router, servers, and firewalls through virtualization. You have VLANs that carve up the switch, local area network. You have virtual routing interfaces or virtual routing protocols to carve up your router into virtual routers. So today, talking about EtherChannel, you can combine the interfaces into a larger virtual interfaces, the physical interfaces into a larger virtual interface. EtherChannel was developed in 1990 as Cisco Systems purchased the technology in 1994. We can use port link aggregation technology to group the individual interfaces. So we use the port link aggregation technology to loop the individual interfaces together. You can group up to 8 Ethernet ports. Depending on the bandwidth, you can maximize up to 80 gigabytes per second of bandwidth. EtherChannel uses existing layer 1 network cabling, giving another advantage over other protocols, and it also is a scalable protocol. So if you start out with 4 interfaces and your bandwidth usage gets high and you want to switch up to 6 interfaces, you can scale that out without having to do much physical reconfiguration to your topology. All the interfaces in the port channel group share the same MAC address, so the users see one logical virtual link. This makes each channel transparent to the end user devices. So no matter how many links you have in your EtherChannel group, your switch or your servers or whatever's on the end, the access layer, they see it as one device. It just has a lot more bandwidth for them to use. So with that said, EtherChannel can lose one or more interfaces and still remain up. Traffic is redistributed across the up interfaces automatically. When the down links are restored, they will be placed back into the port channel group automatically. This is called auto discovery on the link. So now what we're going to do is we're going to configure EtherChannel on switch 2. And first we look at our topology here. We see we have 2 interfaces going across from switch 1 over to switch 2. These interfaces are the gig Ethernet 01 and the gig Ethernet 02. And right now you see they're administratively down. I shut them down. So what we're going to do is we're going to configure them real quick here. So we're going to go config terminal. Interface gigabit Ethernet 0/1 and do switch trunk. So you have to change the trunk and encapsulation to .1Q first on your interface. Then you're going to do, we're going to change these to trunk interfaces to carry multiple VLANs across the trunk. So we're going to put it in channel group 1 and we're going to set the mode to active. This is going to place the port in the EtherChannel right away. Now we're going to go to gig interface 2. So we're going to exit interface 0/2. And then we're going to do the switch port trunk encapsulation .1 kit. We got to change the encapsulation first. We'll change it to a trunk port, and then we're going to do the channel group mode 1 active for this channel group. Okay, so now we had that portion of it set up. So what we need to do next is we got to do the no shutdown, because I did shut down the interface. So we're going to do no shutdown on number 2, and then we're going to do exit interface gig 0/1, and then no shut down. Okay. All right, so now we're going to come out of here, and we're going to show, and we see how gig Ethernet 01 is up, gig Ethernet 02 is up, and we have a port channel interface that's showing up as well. So now we're going to see if we see any MAC addresses on our port channel. And we do see one MAC address on the port channel. All right, so now we got to combine 20 gigabytes between switch 1 and switch 2. So now we have a PC off of switch 2. So let's check switch 2, show VLAN. Check out VLAN. So we have VLAN 20 has classroom. So just show interface VLAN 20. And the interface for VLAN 20 is up. And let's do a show run. It has an IP address of 10.10.10.5.255.255.255.0. So what we want to do is we want to be able to ping our PC from our PC to switch 2 and up to the router. So let's do this here first. PC2, going to PC2. IP config shows that there is no IP address on this switch right now. There's no subnet mask and no gateway. So let's change that, folks. We're going to do IP, and where was it? 10.10.10. Let's do 6 here. 255.255.255.0. Okay, and then we're going to do default gateway 10.10.10.1. Okay, and so now if we try to ping the switch 10.10.10.5, we see our ping fails. So we know our configuration is not complete. So we have a VLAN interface configured on switch 2, and we have the NIC card configured on PC 2. So we go back to switch 2 and show VLAN. And what is our problem here? We're looking at this, we see VLAN 20 is active. It has port FA0/1 in it. All right, so let's do our show CDP neighbor. And FA0/1 goes back to the router. And the gig 1 and the gig 2 is going back to the switch. So what we need to do is do a show IP interface brief. And we see that we have VLAN 20 interface is up, FA0/1 is up, and FA0/2 is up. So my assumption would be the FA0/2 connects to PC2. So what we're going to do here is we're going to do config T interface FA0/2, and we're going to put switch port mode access, switch port access VLAN 20, and then we're going to do description to PC2, and then we're going to come out of here, and then we're going to do that show VLAN brief again, and now we see port 1 and port 2 is in VLAN 20, the classroom VLAN. So let's go back to our PC and see if we have better success this time with the ping. And the ping is working from PC2. So let's see, from the PC2 we can ping our router. And we can ping our router from PC2. So what we have now is we have connectivity from PC2 to switch 2 and then up to router 1. So we have established configuration. So we configured our port channel and we established configuration. So if we do now, if we do go back to switch 2 and we do show table interface port channel 1, we got that one MAC address here. So let's go over to switch number 1, and we're going to shut down this interface that connects to PC1 over here. Alright, so that interface is now up, and then we're going to go back to switch 2, and we're going to let's do this right here. Let's go to PC2, ping, and let's go to PC1. I'm going to ping, and we're going to go back to switch 2 to see if we have any update on our MAC address table here. Still showing the one MAC address, and it seems to be going up and down, but our EtherChannel interface is up, and we have traffic going across the EtherChannel, and our switches are able to ping back to router 1. In the next video, I'm going to configure routing so PC1 can actually communicate with PC2. And I want to thank you for viewing. Have a good day.